Hello colleagues, this is a final project presentation for Big Data Analytics by Dima Galat. The topic of this presentation is using Neo4j in economics. The goal of the project was to use graphs to model and analyze economic trade. Graph is a mathematical structure used to model pairwise relations in data, which represents a robust abstraction for analyzing relationships in data with many connections. Graph data was a center for many developments in the last 2 decades. Google became famous for finding a way of capturing, storing, and querying graph of World Wide Web. Facebook built social media graphs intended to reinvent marketing, and Twitter does the same for media. Focusing on relations provides a different perspective on the domain of discourse. We explore an application of graph data model to economics, and more specifically we would like to analyze trade, which has a lot of individual connections between countries. Storing, analyzing, querying connected data requires different approaches and tools. Many relational database management systems just aren't up to the task. Chart below represents all the joins that a relational database management system would have to perform in order to just return this simple graph. Instead, other database management systems developed optimizations for efficiently storing, indexing, and searching these different types and volumes of data. Specifically, graph databases present a very good model for dealing with data with many connections. They would provide query speed improvements and serve as an intuitive representation for a trade dataset that we are interested in. Specifically, the dataset that we're interested in is bilateral trade flows between states from 1870 to 2014. This is a relatively large dataset containing 1.3 million rows. Neo4j is an open-source graph database which supports ACIDIC transactions and a variety of platforms. Community Edition is limited to running on one node, but Neo4j technologies sell extensions for high availability, horizontal scaling, and hot backup. Neo4j uses a powerful query language called Cypher, allowing to quickly retrieve nodes and relationships between those nodes. OpenCypher is a project that manages the specs of the language, and it is open source, which means that other developers can integrate and use it in their products. Neo4j comes with a web interface, which can be used for exploratory data analysis. We start by installing Neo4j. If you're using Windows, just download Community Edition installer and run it. Start the server by clicking the Start button. On apt-based Linux, follow those instructions to first install Java 8, then configure Java 8 environmental variables, then finally add Neo4j PGP key, add a repository and sources, get the package, install it, and start the daemon. On YUM-based Linux distributions, I had several issues trying to get all the dependencies on CentOS 6. If you're using that distribution, I would recommend compiling from the source. Navigate to localhost 7474 in your browser and use Neo4j as a username and a password to log in. You will need to create a password on your first login. Graph model is a very interesting thing for discovering and interpreting relationships between countries. First time I had a go at it, my intuitive impulse was to model every node in a graph as a country, which resulted in a very busy and hard to analyze graph, because you cannot follow every arrow in a very large graph. Instead, using 2 distinct node types in a graph provides a clear visual distinction between importer and exporter. Both node types have a country name associated with a node. Relations are named after a year when they occur, and they carry a value indicating trade value in millions of US dollars. Using blue to represent exporter and green importer gives a clear visual distinction between node types. When we use a web interface data explorer tool, it allows us to almost immediately get a very interesting perspective of the data. Specifically, by looking at 1876, we can see a few interesting things, like the fact that Russia imported almost 5 times more than it exported in that year, indicating strong outflow of funds. Germany imported almost 10 times more than it exported, which is somewhat concerning. Analyzing individual ratios between the countries might have been less productive than just looking on the amount of economic activity flowing between them. We can conduct the same experiment for 1919, a year after World War I has ended. We can see that United States emerges as a center with massive amounts of trade to Japan, Cuba. France becomes the biggest exporter in Europe, and Russia isn't doing so well. Fast forward to a year after Second World War has ended, and we see a very different picture. The economic activity was basically devastated by the war, with the US being the only country that shows any kind of economic activity. In 1991, we see that the trade is booming, and we even had to restrict the relationships to trades over 100 million US dollars. Well, we can still easily see that Japan, France, and Germany emerge as region leaders, with most trades flowing out of them. US retains influence in America, and interestingly enough, India has very small amount of export relative to its population size. This tool allows us to explore relations in a different way, which is highly consistent with exploratory analysis patterns that one could use. If you're interested in getting more concrete numbers, using rclient and Cypher to work together is a great way of retrieving information in a matter of milliseconds. Here I'm showing how to retrieve data for a particular year, and then I'm using regular R to just sum it by a country name, and do min-max scaling for a particular group to represent relative size. Finally, I'm returning it in decreasing order size. So if I execute get year total 1969, I get top 3 exporters with relative sizes and their trade values. Economic trade data can be efficiently and productively analyzed using R and Neo4j. If you have large quantity of data, it could take a long time to import it to Neo4j. 1.3 million rows that I use took about 24 hours. I tried creating an export and extending a record set to 10 million relationships just to see how it would do, and requests are still matched in milliseconds. So it's still worth investing the time in importing the data into Neo4j, because it's a fantastic tool for graphic data analysis. Model used in this report can be used with any kind of economic trade data. For example, UN Comtrade provides information about specific resources. You can simply add another attribute to a relationship, which is consistent with how Neo4j authors describe their model. Exploratory data visualization tool provided by Neo4j leaves a lot to be desired. D3 based implementation lags and doesn't work with more than 500 nodes. I've tried several other D3 based projects on GitHub, and I don't think that D3 works with over 2000 relationships. Sigma.js is a solution which could be a viable alternative for some of you, because using WebGL based visualization allows to work with tens of thousands of edges in the graph. Linkcurious.js, which is based on Sigma.js code, is a higher level visualization abstraction, and unfortunately, since it became a fully commercial project, there aren't any good visualization tools that I would recommend. But it's worth having a look at Linkcurious.js itself, because it provides a good example on how you can create a good visualization tool based on Sigma.js. Thanks for your time.